Okay, here's an Alex question regarding stoichiometry and heat. And so the question is, a chemist measures the energy change, the enthalpy change during the following reaction. We have here methane plus oxygen. It's a typical combustion reaction that's going to give us CO2 and water. And when it does that, it produces 882 kilojoules of heat. The negative here tells us that it is exothermic. It's going to give off heat. And so that means that for every 1 mole of methane, then we're going to generate 882 kilojoules worth of heat. And for every 2 moles of oxygen, we will generate 882 kilojoules of heat. For every 1 mole of carbon dioxide created, we generate 882 kilojoules of heat. And for every 2 moles of water, we generate 882 kilojoules of heat. And so let's answer these following questions here. This reaction, because there's a negative charge, it's going to give off heat. This is definitely an exothermic reaction. Alright, suppose we react this many grams of methane. Will any heat be produced? Well, we know heat is going to be produced because that's what happens in this reaction. And so without even doing any calculations, we can say yes, heat is definitely going to be released here. And then it says how much heat is going to be released or absorbed. Well, we're going to have to do some calculations for that. So we start off with 66.0 grams of our methane. Okay, we know we have to convert that into moles. Okay, so there are approximately 16 grams in 1 mole of methane. And I have to look at my stoichiometry and that enthalpy. And so I know that for every 1 mole of methane, I'm going to generate 882 kilojoules worth of heat. And so for every 1 mole of methane, then I'm going to generate 882, with negative there to show that it's exothermic, kilojoules worth of heat. And so when I put that into my calculator, I get 38.25 kilojoules worth of heat. Obviously I have to worry about sig figs here. I have 3 sig figs right here. I am given 3 sig figs right here. And so if I do that, that's going to be 3640. There's 3 sig figs kilojoules. That's one way of writing it. Sometimes Alex prefers it in scientific notation, so we can change this to 3.64 times 10 to the 3rd kilojoules. Either one of those answers are right. They are equivalent, and that is how you handle stoichiometry problems. So again, know that and that a negative sign on your heat means that it is exothermic, meaning heat is released. Also know the stoichiometry that in this case turned out for every 1 mole, but let's say that we had oxygen. We would have to know that for every 2 moles of oxygen, we generate 882 kilojoules of heat. These problems are definitely very doable.